Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, will that robot behave ethically? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and in today's episode, we're exploring robot ethics. What does it mean for a robot to act in an ethical way? And what guidelines and safety nets can we put in place to protect us when things go wrong? Before we get started, this is your regular reminder that you can contribute to the conversation by sending in questions for my future guests. I announce upcoming guests on social media and Patreon, so make sure you follow the podcast to find out what's coming up. You can submit questions on the website at robottalk.org, on Patreon at patreon.com/Claire Asher, or by replying to one of my guest announcements on social media at Robot Talk Pod. So, with all that said, I'm excited to introduce this week's guest. I recently had a thought-provoking chat with Alan Winfield from the University of the West of England about developing new standards for ethics and transparency in robotics. Today, I'm chatting to Alan Winfield, a professor of robot ethics at the University of the West of England, researching ethics and transparency in cognitive robotics. Hi, Alan. Great to have you on the podcast.
Hi, Claire. Yes, I'm delighted to be here. Thank you for the invitation.
So I'm really excited to talk to you about robot ethics. I think most listeners will probably be familiar with the 3 laws of robotics. That's probably the first place that people's minds go when they hear robot ethics. And of course, these were developed by science fiction author Isaac Asimov and featured in the movie I, Robot. So how relevant are these 3 basic laws in robot ethics today, and how far have we kind of come from there?
Well, that's a great question because, in fact, I co-convened a meeting, I think it was in 2010, with the aim of creating some kind of guidelines for robot ethics. Mm-hmm. And they became known, and they were published a year later, as the EPSRC Principles of Robotics.
Okay.
And, I well remember that the first thing that we started talking about was Asimov's laws of robotics, because it's a great starting point. So essentially, they became a kind of template. In fact, the first 3 of our principles of robotics echo, if you like, Asimov's laws of robotics, except they're principles for humans.
Okay.
And then we added 2 additional ones because we thought they were really important too. So the 4th one that we added was that robots should not deceive.
Okay, yeah.
And I think that's particularly interesting in the current context of deep fakes and the like. And that the nature of the robot should always be present. So in other words, we wanted to make sure that robots identified themselves as robots, which has interesting applications, of course, for android robots that look exactly like people.
Yeah.
And then the 5th law that we added, or principle, was that all robots should be registered in some way.
Okay.
Should have a label that, if someone comes across the robot in a shop or something and the robot is behaving strangely, it has the manufacturer and some kind of way of contacting the manufacturer or the person responsible for the robot.
Like a robot passport.
Kind of, yes, that's a good way of putting it. Yes, indeed.
Okay. And of course, Asimov defined these 3 laws and then kind of spent a lot of his science fiction books exploring what happens when they go wrong, or the edge cases, or kind of the nuance there.
Exactly right.
How much of those kind of scenarios do you consider when you're thinking about robot ethics or when you were developing these principles?
It's a great starting point. In fact, you'll be amused to hear that I was even interviewed for one of the additional videos on the kind of special edition of the movie.
Oh, cool.
And the other thing I should say is that I've actually built an Asimovian ethical robot in the lab.
Okay.
It was a really nice set of experiments that, fortunately, I had brilliant students who could actually do this.
Mm.
And we demonstrated the robot essentially saving or preventing another robot, which was acting as a kind of proxy human. And we demonstrated that in the lab. And then, we wrote the paper and so on to disseminate the work. And I said to the guys, look, it's a bit dull because we've basically done an experiment and it works. I said, why don't we add a second human?
Okay.
Proxy human. So we then had two robots pretending to be humans moving towards a hole in the ground because there wasn't a real hole in the ground.
Mm-hmm.
And I think that that's the first ever experiment with a real physical robot facing an ethical dilemma.
Mm.
And of course, it's the dilemmas that make Asimov's laws interesting.
Yeah. It's a little bit like the trolley problem, I guess, that one.
It is a bit like the trolley problem. It's a bit like, the dilemma that you and I would face if, imagine that we're at the seaside and we see two children both rushing into the sea when it's dangerous. What do you do then?
Yeah, there are no easy answers to that.
Exactly, which is why I think dilemmas are particularly interesting in machine ethics.
Yeah. The additional principle you mentioned of the robot can't deceive, I think is quite interesting because, how do you define deception and are there some kinds of deception that are good? The scenario I have in my mind is like the kind of healthcare scenario where a robot has some personal data about its user and it doesn't want to then disclose that to somebody who's asking about it. So it might need to deceive in that scenario, but it's for the greater good.
Yes, it's certainly an issue that we've explored, or I've explored with my postdocs in relatively recent work. And this is in the context of human-robot interaction, and especially assisted living robots.
Mm-hmm.
And of course, assisted living robots most often means robots keeping an eye on elderly people.
Mm-hmm.
So the robots might not be very smart, which they're not, in fact, very smart.
Yeah.
So the robot might have very simple aims, like reminding you to take a glass of water.
Yeah.
Or reminding you when it's time to take your medicine. And they would also be avatars for the family to be able to keep an eye on, granddad or whatever. And certainly, of course, the robot is collecting very personal data, or at least in principle, can collect that data. And you would then need to have appropriate consent from family to collect data. In some cases, of course, the family or the subject, the elderly person themselves, may say, no, I want my data deleted, at the end of each day, for instance.
Mm.
In fact, I was part of the ethics advisory board for the Human Brain Project. What they were looking at there was how to anonymize brain scans.
Mm.
And what I learned then was that there are sophisticated ways of anonymizing data. And the reason that you need to keep data is because, yes, robots go wrong. They're physical things. They break, they fail. And it's important that we should find out why they fail, when they fail, not if, when. Of course, all machinery fails from time to time.
Yeah.
So, accident investigation, I think, is profoundly important. And that's why I think, and I wrote this paper with my colleague, Marina Jarotka, basically setting out the case for an ethical black box.
Okay.
It's essentially the robot equivalent of a flight data recorder.
Mm-hmm.
It's just a data logger. There's nothing fancy about it. And we called it an ethical black box because we thought that it was important to stress that it would be unethical to not equip a robot with such a device.
Mm-hmm.
Because if you don't have data, you cannot find out why the thing that went wrong.
Yeah.
And I don't know if you've come across it, but there's a fantastic crowdsourced database called the AI Incidents Database.
I haven't heard of that.
Yes, you should check it out. It's really, really good. In fact, I met a couple of the guys at a meeting in Paris last year that actually run it. Okay. And essentially what they're recording, what they're logging is accidents. Now, most of them are, of course, AI accidents, and that includes, fatalities, because there have been fatalities as a result of AIs, but it also includes physical accidents of both robots and, of course, autonomous vehicles, which are essentially robots, while they're in full driving mode, as it were. And I saw only recently that there was a young woman injured by one of those delivery robots.
Oh, yeah.
In fact, we have them in this country. We have them in Milton Keynes. They've been there for quite a while. And apparently they're going to be installed also in Bristol.
Oh, okay.
But this was in the US. And apparently one of these robots crashed into a young woman, knocked her off her feet, and then continued to bash into her while she was on the ground, I mean, I don't think she was seriously injured, but nevertheless, it's an accident.
Yeah.
And accidents like that need to be investigated, because that's the only way that you can make sure they don't happen again.
Yeah, absolutely. So we've touched on, a few different use cases of robots so far in our conversation. Are there any areas of robotics that you think are particularly vulnerable to ethical issues?
Well, it's hard to think of areas that are not vulnerable.
Yeah.
So any robots that interact with humans, and that, of course, includes medical robots, surgical robots. It certainly also includes workplace assistant robots. So if humans are in the same physical space as robots, and of course the old-fashioned industrial robots, which are still millions of them in the world, they're typically, of course, kept inside a safety cage, and the humans are kept, physically separated because they're dangerous robots.
Yeah. So another area that is kind of adjacent to this, I guess, that you're working on is transparency in robotics. So we have covered transparency a little bit in the past, but, for people who aren't familiar, what is the difference between ethics and transparency? Can you have one without the other?
I would say no. So transparency, I define very simply as the ability to find out why a particular thing happened. And that means in the context of autonomous systems, which is broader than just robots, why did the robot or the autonomous vehicle make that particular decision?
Yeah.
And without transparency, you cannot discover that. In fact, the standard that I led, an IEEE standard, it's called 7001, and it was published, I think, in early 2022. And it's the world's first technical standard on transparency. And I'm very proud of it. I mean, it was immensely hard work, 5 years of hard labor. And I'm especially proud of the fact that we were able to write a standard with measurable, testable levels of transparency.
Okay.
It's a standard that you could build a robot and then test it against the standard and describe the conformance of that particular robot or autonomous system, with the standard.
Mm-hmm.
One of the things we wrote, in fact, in the standard was that, of course, without a data logger, you have no transparency.
Yeah.
But transparency is more than a data logger. So it's a bigger thing than simply logging data. That's a key part of transparency, particularly for physical systems. So, yes, transparency is super important in my view.
Mm-hmm. So you mentioned there are different levels. What is the kind of gold standard of transparency? What would you like to see in all robots?
I'll give you some examples, and I'm going to, I'm going to stretch my brain a bit here. But essentially, we split the standard. It's like 5 standards in one.
Okay.
Because we have transparency for users. We also have transparency for safety certification agencies. We have transparency for accident investigators, which is something I've just been talking about a lot. also transparency for lawyers and expert witnesses. So I can't, I mean, there are 5 categories. I've only listed 4 of them.
That's okay.
But to give you an example of users, we divided that into a number of categories. So level 0 is no transparency. Level 1 would be, is there a manual for the robot? Simple, nothing particularly difficult about that. Level 2 is there a manual that allows you to simulate your interactions with the robot? So in other words, it's like a robot simulator enhanced manual. Oh, and a very important thing is that these different levels, we ended up in the revision because, of course, standards, you don't just write them and they're published, they get peer reviewed every bit as much as journal papers. And as a result of that review process, we split users into naive users, and that's, ordinary, everyday people who might come across a robot, perhaps in a museum or something. And then we have people who are responsible for the robots.
Right.
Then we have people who repair the robots and maintain the robots. And we came up with quite a nuanced list of kinds of users. In other words, with different kinds of expertise. So you have domain experts. So, for instance, think of a medical diagnosis AI. Mm-hmm. Well, a clinician is clearly a domain expert in the particular medicine that their expertise is in, and they might use the AI as a second or a third opinion. Now, they won't understand how the AI works, but they should be able to say to the AI, why did you come up with that diagnosis? Explain your thinking, your rationale for coming up with that diagnosis. And that's a higher level of transparency for that particular domain expert.
Yeah.
And you can go even beyond that and have a domain expert who also understands, as it were, the inner working of the system of the AI. And of course, if it's a physical robot, then clearly there have to be people who can repair the robot and understand exactly, how and why it made particular decisions, which the domain expert may not. And, we have, as I say, expert witnesses and lawyers. And so, we ended up writing, in fact, really 5 standards in one for each of the categories. We call them stakeholders. Mm-hmm. And I think another thing I'm very proud of is that we ended up writing quite a lot of appendices. So we wrote a method for setting out a system transparency specification. In other words, how would you define, before you start to design a system, the levels of transparency it needs? Mm. And then we had also a system transparency assessment, which is how you'd measure the transparency of a system that already exists. And then we followed that with a whole load of worked examples.
Amazing. It's a huge body of work and a much more complicated and multifaceted issue than I had initially imagined.
Well, I think, and me too. It was a process of discovery and learning.
Yeah.
And of course, an international process, but I was very lucky that we had a core team of around 15 or so working group members who stayed with the working group for the whole 5 years.
Brilliant.
Which doesn't always happen.
Yeah, of course. Yeah, that continuity is very helpful. So we had some audience questions that I want to make sure we get to. So first of all, Kieran on Facebook says, is there scope for a defined code of ethics that robots could conform to? Who would be responsible for coming up with that? And how do we decide what is and isn't ethical for a robot to do?
Well, yes, in fact, there are codes of conduct. I just outlined one. Mm-hmm. Well, 2, in fact. One is to do with making sure that you can log what a robot is doing. The other one is making sure you can then discover why it made particular decisions. But standards themselves have no teeth. What you also need is regulation. And I'm very pleased to see that regulation is beginning to appear for AIs. And by extension, I think that regulation also applies to physical robots. And what I learned as I was kind of working through all of this is that you not only need regulation, of course, you need regulators. And we have those already in the UK. So if a physical robot, is in a workplace, and that means it could be in a hospital or it could be in a factory, or even if it's in a shopping mall and there's an accident, then it's the health and safety executive that is responsible for actually figuring out what went wrong. Now, they might not have a team that necessarily could do that, on hand, but they could very quickly put one together. I mean, typically what they do, and this has happened in healthcare accident investigations, is that you start with an aviation accident expert, because that's the gold standard, and then they appoint domain specialists to come with them, with the person with the lead, to actually then figure out what went wrong. So I'm reasonably confident that the health and safety executive would be able to investigate accidents. And interestingly, and it wasn't really publicized very much, but a couple of years ago, the Office of Road and Transport did actually announce the creation of an autonomous vehicle accident investigation unit. Now, happily, I don't think there have been any fatalities, if you like, that you can pin on the autonomous functions of an AV. And partly that's because, of course, we have different rules than in the US.
Yeah, I was going to say that, yeah.
That Teslas are not allowed to do some of the things that they do in the US. But certainly I was very pleased to see that bureau exists.
Yeah, I mean, I think it's still the case in the UK that, if you're in a vehicle with autonomous features, you are still responsible as the driver, right? Like, you have to be ready to take over at any moment.
That's right. Exactly right. Yes.
So, hospitals, workplaces, roads are already quite heavily regulated places.
Absolutely, yes.
I have a robot vacuum cleaner. There's no health and safety rules. It's in my house. Do you think that that's an area that's being left out of kind of robot ethics?
It is. It's the missing bit of robot ethics. That's certainly true. I mean, on the other hand, most pieces of domestic machinery, your toaster, your kettle, your washing machine, there are standards for those.
Yeah.
And there are certainly safety marks, CE marks and such like. So I would expect that manufacturers who want to sell as robot vacuum cleaners will have really paid attention to the safety. And of course, getting a CE mark will differentiate one robot vacuum cleaner manufacturer from another. So there's commercial advantage to getting, your piece of kit checked over. Yeah,
absolutely. So we had another audience question. This is quite a broad one, quite a big topic. So Laws of Robots on Twitter said, is there anyone in government concerned with the imminent societal issues brought on by the prominence of robots?
Well, yes. Interestingly, I was invited, this is some years ago, to both Commons and Lords select committees. So I've submitted evidence to both a Commons select committee, that was in writing, but face-to-face, a Lords select committee. I've also been part of several, and this is more recently, round tables. One was in person, which was organised by the BEIS. And I've also taken part on online, I think it's called Policy Connect roundtables. And typically they're chaired by one or two Lords. And I've got to know several of the Lords, and they really know what's going on. And I've attended several events in person in Parliament. And of course, I have to keep telling myself, this isn't government, this is Parliament.
Yeah.
It's not as influential as you might think. But nevertheless, I think it's really good that there are senior MPs. Chi Warha, I'm not sure if I pronounced the name correctly, is a chartered engineer in the Commons. And she's certainly, I've met her and we've talked about robots as well.
Yeah, it's good. It's good that it's on the radar, I guess. As an outsider, it seems like there's more attention on AI at the moment than robotics.
Well, I think, to be honest with you, Claire, I think that's right. Because the dangers that we're facing in AI are much more present than they are in robotics. It may not be the case forever. Designing and building a physical robot and actually getting it out into the world it takes a long time, and it takes a lot of really good engineering. Providing you've got enough money and therefore you can buy the computing power, then making a new AI is not that hard.
Yeah.
The technology is very well understood. And that's what makes AI much more dangerous, in my view.
Yeah, that makes sense. And I guess as well, a lot of the ethical issues that arise from AI will also apply to, intelligent robots that we invite into our homes, into our care homes, into our hospitals.
Yeah.
With an added layer of all the potential physical, ethical issues on top of that.
Yeah. Yeah. Well, there's an interesting point there, Claire, which is really relevant to this. So a lot of people are talking about putting LLMs into physical robots. And at first I'm thinking, no, don't do that. But of course it's inevitable.
Yeah.
Of course, the thing about LLMs is they don't have a world model. So what is a world model? Well, you and I have a world model. We know what it feels like to be wet or dry, or what gravity feels like. You and I experience it every day, You jump off a chair and you know what gravity feels like. And robots need all of that as well. So this is a good opportunity to tell you about the work the technical work, not the ethics work, the technical work that I'm most proud of, which is that I put a simulation of a robot, including a world model, so including physics, into that robot.
Okay.
And I think I was almost the first, not the first. I know the guy who was the first very well, but I was among the first to put a simulation of a robot of itself, and therefore other robots like it, conspecifics if you like, together with a world model into the robot. And, right at the beginning, I mentioned, building the ethical robot experiments in 2014. And that was using a world model. So the robot, the Asimovian robot, the one that was able to save other robots from falling into a hole, was able to simulate what the other robot might do next. Another way of putting it is that you've essentially given the robot a simple kind of theory of mind. In other words, it can anticipate the actions and intentions of another robot. So, I think that world models are profoundly important. And a robot with an LLM that does not have a world model is useless.
Yeah.
Completely.
And where LLMs have been able to be developed off the back of all of this, the entire internet basically of data, there isn't that physical world model data out there.
No, that's right. Because the truth is, of course, that an LLM will know what word is likely to come after the word hot or cold or heavy. But that doesn't mean that the LLM understands what those words mean.
Yeah.
They don't. They can't. They're just, word predicting machines.
Exactly.
Stochastic parrots, I think they're called sometimes. So, of course, we have language too, but we learn about our physical bodies and how to control our physical bodies long before we learn language.
Yeah.
Literally, as infants, a few weeks old, we're starting to learn about our own physical bodies and how to control them.
Yeah, absolutely. So you have co-drafted new standards for ethical risk assessment in robotics. So can you tell us a bit about this work?
Yes, so this is BS 8611, and we started working on it, I think, probably around 2010. So, it overlapped pretty well with the IEEE standard that I was working on. Basically, the BSI set up this working group, which still exists, And we worked on it for a number of years, as you do with these things. And the standard was first published in 2016. We then revised the standard and extended it a bit because we realized that there were some things missing. And it was republished as a second edition in 2023.
Okay.
And I think it's an incredibly powerful standard, not because necessarily the standard works for everything, but because it provides a method. And, the papers that I've written, a number of papers, which are case studies of using the standard, those case studies show that you don't just stick to the examples given or the risks that have been articulated in the standard. You add additional risks which are appropriate because they were simply not considered or thought of at the time of the standard. So it's the method that's set out in the standard, which is the thing that makes it the most powerful. And as I say, I think you should apply ethical risk assessment to everything, really. And, one of the papers I wrote quite recently, or co-authored recently, was where we actually applied, I think for the first time, we systematically thought about ethical risk assessment for swarm robot systems in the real world, which is something that nobody really considered before. So working with my colleagues at the University of Bristol, Sabine Howard in particular, and her colleagues, we came up with a set of plausible near future scenarios of deployment of robots. One example, I think, was delivery robots, a swarm of delivery robots in a neighborhood. Another one was small robots that would monitor pollution in a lake or in a river. And we came up with 5 scenarios. One of them was kind of quite science fiction-y. It was nanobots for cancer treatment, which is a particular specialism of Sabine's. And what we did is we applied the method of BS 8611, ethical risk assessment, to all of those scenarios.
Amazing, yeah.
And it's quite a recent paper, and I'm really very proud of that work, the work we did on that, because it really takes the envelope, if you like, of ethical risk assessment beyond singular robots, but to robots in the real world.
Yeah, Sabine has been on the podcast before. Her research is fascinating.
It is, yeah, she's a star.
A lot of people listening may be familiar with doing kind of standard risk assessments in their jobs. I think it's brilliant to have an ethical version of that. I think that's a gap that really needed to be filled.
Absolutely, yes. And of course, ethics, sometimes people say, well, isn't ethics just safety plus? And I say, yes, absolutely. It's safety plus, plus, plus. Because you're not just considering physical risks, you're considering psychological risks, risks to society, to the environment, even risks to democracy.
Yeah.
So you're broadening the envelope of risk to way bigger than physical safety.
Yeah.
Not that physical safety is not important, it's fundamentally important.
Yeah, absolutely.
And in fact, I was going to say that one of the things that I'm particularly proud of in the project where we staged a number of robot accidents with humans, volunteers, one of them, we wrote a scenario. My colleague, Pericles Salvini, wrote a beautiful script for an accident, a robot accident, where the robot caused psychological harm over a long period of time, which is what you might expect. And, it was an interesting scenario. We imagined a teenage girl with a robot companion.
Mm-hmm.
And we imagined that the robot companion had been maliciously hacked and converted. It's not implausible. It's entirely possible. And converted from a benign, friendly robot into an increasingly aggressive robot and hateful, So we're imagining a robot that has speech recognition and speech synthesis and so on, which is actually normal these days. And it was fascinating to actually explore not only an accident that doesn't, as it were, have a singular event. The harm isn't something that happens in an instant. It's something that happens over months or perhaps even years. And the real challenge was then for the accident investigation team looking at the logs over, a lot of data logs, including, of course, samples of conversations, So that was really, really interesting. And I think it just illustrates the power of and the need for ethical risk assessment, where the word ethical makes all the difference.
Yeah, I mean, it strikes me that in your line of work, you end up having to spend a lot of time thinking about the sort of most unpleasant and darkest scenarios.
Yeah.
But I guess that's necessary in order to prevent them or protect us against them.
Absolutely, yes. So dear friend Shannon Ballard, professor in Edinburgh, she was the first to suggest that really you need a kind of radical brainstorming process.
Yeah.
And that works better when you have a lot of stakeholders. So it shouldn't just be engineers. In fact, engineers are probably the worst people to do the brainstorming because, of course, we think that our creations will never go wrong. So you need to bring in other stakeholders, the users, bystanders, all of the stakeholders with respect to, for instance, robot toys. That means both children and their parents, and brothers and sisters, and family. Because, it's no good just people like me trying to think what might go wrong. That's not going to work.
Yeah, absolutely. Alan, it's been fascinating talking to you today. I've been speaking to Alan Winfield from the University of the West of England. Thank you.
Thank you so much, Claire. It's been an absolute delight to discuss with you.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. And don't forget to join the Robot Talk community on Patreon if you'd like to support the podcast and get access to some awesome perks, including monthly bonus episodes, behind-the-scenes updates, merch discounts, and more. Visit patreon.com/Claire Asher and join the Robot Talk community today. Next week, I'll be talking to Crystal Matic from BrainCorp about robot safety and security. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.